Welcome to this lesson about solving clock problems, and we have an analog clock shown here in the screen. I would like you to observe the movement of the hands in this analog clock. So I'm holding on the minute hand, which is color green. We will start at 8 o'clock shown here, and we'll be rotating the minute hand clockwise, of course it's clockwise, until we get to 9 o'clock. So the minute hand is turning 360 degrees, and as you can see, the R hand, which is color orange, will go from 8 to 9, and the R hand completed a 30-degree rotation around this portion of the circle. So this part here from 6 to 9 is 90 degrees. Also here 9 to 12, 90 degrees. And here we started at 8. We started at 8, and then the R hand moved to 9. It covered a total of 30 degrees for that 1 hour of time. And also, if we interpret the motion of the R hand and convert it into, let's say, the scale of the minute hand here, as you can see the scales here at the side, you can basically say that the R hand has moved 5 minutes. And that is what we're gonna do with our approach. We're gonna interpret the movement of the R hand as in terms of minutes, because if we're solving algebra problems, it is important to use consistent units in order to do operations on it. So we of course know that 60 minutes is equal to 1 hour. And in terms of the degrees covered by the minute hand, it is 360 degrees and 30 degrees for the R hand. So what we're gonna do is to convert in terms of the minute scale. So for this row, minute scale, I'm talking about the scale you see at the side of an analog clock. So 5 minutes, 6 minutes. And we're gonna do a ratio to that. So here, the ratio we're gonna do is the movement of the R hand, our hand movement, HHM, so we're gonna use that, and then minute hand movement. Alright, so what we have here is the R hand movement over the minute hand movement. So in 1 hour, so this is for 1 hour, I'm making a ratio for what happened for an hour. The R hand has moved 5 minutes, and the minute hand has moved 60 minutes. 30 degrees, 360 degrees. And the ratio here is 1:12. Let's simplify this further to just capital H, this one to capital M. So what we have here is H over M, that is the movement of the R hand relative to the movement of the minute hand. It's 1/12. And then H is equal to M times 1/12. Alright, so we're going to use this ratio, and then let's see. After 30 minutes, we know that the R hand will be somewhere in between 9 and 8. We have scales here, right? 1, 2, 3, 4. And we know that after by 8:30, the R hand will be somewhere here. So on that scale of minutes, we can say that the R hand has moved 2.5, and we're gonna verify it using this formula. Let's see how it works. So after 30 minutes, by 8:30, starting from 8 o'clock, yes, the R hand has moved 2.5 minutes. How do we convert that into degrees? So we're interested to know what is the degrees covered by that movement of, let's say, 30 minutes have passed. So what we're gonna do is, we know that for 60 minutes, the minute hand has moved 360 degrees. Or we can also use a ratio using the R hand. We can also use this one, like for 5 minutes. Like, alright, so after 1 hour, the R hand has moved 30 degrees. Alright, so here 2.5 times 360 divided by 60. The unit minutes will cancel. We have minutes in the numerator and also in the denominator. We'll get 15 degrees. So the degree stays here. And we also use this factor based on the R hand. It's the same. We're still gonna get 15 degrees. So from 8 o'clock to 8:30, this is the degrees covered by the R hand. Now let's clear up the screen, and let's not forget this ratio here. We're gonna solve a basic problem that commonly appears in clock problem exams. Alright, so we have this question: at what time after 8 p.m., after 8 o'clock, will the minute hand overtake the hour hand? So if we use this analog clock, starting from 8, at what time after 8 o'clock will the minute hand overtake the hour hand? Okay, we start here. We're specifically talking about this time after 8 o'clock. And as we can see, it happens around 8:43 to 8:44. But we're interested about specifically down to the exact second. So we know that it's from 43 to 44. So how do we answer this question? We know at the start, the hour hand is ahead. We're gonna draw something here. Alright. In terms of degrees, in terms of minutes, okay, so we're gonna interpret how advanced the hour hand is to the minute hand. This is the hour hand pointing at 8. So we can say that the hour hand is 40 minutes ahead of the minute hand. Hour hand, minute hand. Alright, so we will compute for the time that they will be together. So there's gonna be an equality here. So we're gonna assign the left side for the hour hand and the right side for the minute hand. Why did we use the equality sign here? Because we're gonna compute for the time where they will be equal relative to the start, which is 12. Alright, so at the start, the hour hand has an advantage of 40 minutes, ahead by 40 minutes. And the minute hand will have to move. The minute hand will be somewhere here. Yeah, so this thick line represents the conjunction, and that will be after a particular number of minutes, which we will assign using a variable m. So after m minutes, they will be equal, but of course the hour hand will move by a certain degree, which can be obtained using the ratio that we figured out earlier, and we're gonna place it here. All right. So at the start, the hour hand is 40 minutes ahead. That is 40, and then it will also move by. So basically, for the hour hand here, 40. This is 5, 10, 15, 20, 25, 30, 35, 40 for the hour hand, plus, all right, 40 plus a certain minutes move based on how the minute hand move. So we're gonna solve for m. The first thing we're gonna do is to transpose m to the other side. So that is 1 minus 1 over 12, and this is m is equal to 11 over 12. And we're gonna transpose 12 to the other side, 11 to the other side, so it's gonna be 40 times 12 over 11. That will give us the number of minutes after 8 o'clock. So we start with 8 o'clock, and then m minutes after the hour hand and the minute hand will be conjunct. So that's 43.6363636363 minutes. If you want to know exactly what time will it be down to the exact second, what you're gonna do is to focus on the number after the decimal, which is 0.636363. So what we're gonna do is, we know that it is a fraction of a minute, and we know the conversion that 1 minute is composed of 60 seconds. It will give us 38.18 seconds. So the time that they will be together is 43 minutes and 38.18 seconds after 8 o'clock. And if we check again our analog clock, we see that it is really somewhere in between 43 and 44. And it happens when this second hand is somewhere here. This is 38, this is 39, so 38.18. I cannot actually move this. So it's somewhere between 38 seconds and 39 seconds. So that's it. So I hope you learned something in this video, how to tackle clock problems without the use of any formula. So with that, thank you for watching.